So we're going to talk about quadratic functions here. So we're going to fill out the table for the parent function of x squared. All right, we're going to pick those points right here that we already talked about. We have 0, 0, 1, 1, 2, 4, and we have negative 1, positive 1. I'm going to put an extra point here, negative 2, positive 4. Don't forget that these points are coming, this y coordinates are coming from me squaring 1, 2 squares 4, 0 squares 0, negative 1 squares 1, right? That's where those points are coming from. You must remember those points, because from now on we're going to actually graph this without a calculator. All right, so that's the big deal in the next test. We're going to graph this without a calculator. All right, so the first thing we're going to do on here is we're going to go ahead and graph this. We have 0, 0. Now notice what I'm going to say, because I'm going to say this a lot. From that point, from this point, I'm going to move over 1, up 1. All right, so that's 1, 1. And then from this point again, from the origin, I'm going to move over 2, up 4. Which is, let's see, 1, 2, 3, 4. This is symmetric around the y-axis. So if I get those points, it should be exactly the same. And before you ask, yes, this whole thing is one big function. It's not two functions put together, right? The domain on all the quadratic functions is going to be all real numbers. It goes to the left and right from negative infinity to positive infinity. Now the range is going to be between 0 and positive infinity, like that. Okay. So this is the part we already covered on the parent function chart. Right? So please remember this. Now as I go to the next part, it says graph on the calculator, and if I let you do this, that's going to take a really long time. Right? So what I'm going to do instead is I'm going to show you on this calculator. I'm going to show in this calculator what happens. All right, so the first graph you're going to see appear, that's the parent function, and the next one is this one. What's the difference? What happened to it? I say you're doing that with your hand. It just kind of turn upside down, right? So this is the negative x squared right here. All right, so we're going to start graphing that. So what happened here is that it reflect over x-axis, and I'm going to start graphing them now just so you can get in the practice of it. If they're reflected over the x-axis, all right, we're going to start off at the same exact point that we started in the other one. Now the next point, so you don't have to look at your calculator table, what you do is that the y-coordinates, this y-coordinates right here, this y-coordinates, just multiply them by a negative. So now you would have 0, 0, and then 1, negative 1 instead of 1, 1. And then you would have 2, negative 4. Alright, so that's how that's going to work. And again, I know I'm going to take a long time, but it's going to save you time in the end. Alright, don't worry, I'm going to do about 6 of the problems out of your homework. So, on number 3, let me show you that one. All right, what happened to the parent function? Moved over left or right? Left. Right, it turns out that it actually moved 2 to the left. All right, so that's where we're starting now. So again, that moved to the left too. All right, notice the difference, right? Notice you have a plus 2. That's kind of weird, isn't it? You have a plus 2, but you're moving left. And the way we remember that is I always tell you, remember your ex-boyfriend or girlfriend, and remember they're a liar. All right, so X is a liar. It's always going to tell you the opposite. So on this one right here, we're going to start here. Now you're going to pretend like that point right here, pretend like that point right there is your new origin, is your fake origin. So the coordinates of that point are now 0, 0. All right, so from that point, I'm going to move over 1, up 1, because if you look at the table that I have above here, that's the first point that I'm going to graph. All right, the next one is going to be 2, 4. Do you see what that 2, 4 is on your table up here somewhere? All right, it's right here. 2, 4. That's why I'm getting those points. 2, 4. So from this point right here, I'm going to move over 2, and I'm going to go up 4. 1, 2, 3, 4. Don't worry, kids. I still have like another 20 minutes of me talking. Enjoy it. All right. So left 2. Make sense? All right. On the next one, what do you think is going to happen? If that one was left 2, what do you think that's going to be? Ding, ding, ding. All right, right 2. All right, and the same thing. You're going to start from the origin, and you're going to move over 2. And then to graph this without a calculator, you're going to follow the exact same points. That was very repetitive. All right, so you go over 1, up 1, over 2, up 4, because those are the points that are up there, right? So again, pretend this is your fake origin, and you're going to go over 1, up 1, and you're going to go 2 and 4. All right, so that's that. Okay. So we're not going to have to explain anything. Well, we already did here, so let's move on to the back now. Okay, now number 5. Now, without actually showing you this in the calculator, you're going to have to take my word for it, is that what happens here, when you have a plus 2, that's going to move your parabola up 2. All right, so instead of starting here, I'm going to start here. You're going to pretend that's your fake origin right there. So pretend that's 0.00. And then from this new origin, you're going to move over 1, up 1. Right? And from that point again, notice that the next point is normally 2, 4. So from here, you're going to move over to the right 2, and you're going to go up 4. Okay, does anybody have any questions where I'm getting those points? So I want to make sure I don't lose you here, because it's all the same stuff over and over and over. Right? Remember that I'm getting those points from the very beginning, from the parent function of the quadratic. All right, so that's that. All right. Now on number 6, by the way, what's the difference between notice that this one doesn't have a parentheses. There's no parentheses here, right? So that's how I know this is an up 2, not a left 2. And on this one, no parentheses again, and I have a minus 2, which means I'm going to move down 2. So I'm going to move that parent function down 2 units. All right, and from that point right there, I'm going to pretend this is 0.00. Okay, and then I'm going to move to the left 1, up 1, and then I'm going to move to the right 2, up 4. Okay, so those are my points. Oh, that didn't look very good, but all right, that'll work. All right, so that's where we're at right now. Okay, number 7. Number 7 gets a little bit more complicated, but I'll show you what to do here. Now, when you have a 2 here, actually, let me show you that on the calculator real fast. Everybody's like, oh my God, let me get on my phone real fast. No. Back in my day, kids, there was no phones. All right. So this one right here, the first one is the graph of the original, and the second graph you're about to see, the one with the thicker line, is this one right here. Now, obviously, I made the line thicker. That has nothing to do with the function. What happened to it? So again, what happened to it?
Got closer.
It kind of got like this, right? It got a little more narrow, right? And some people say, well, it got skinnier, and that might be true. But the way we're going to describe this is we're going to describe this as a vertical stretch. And just to make sure you understand that, right? If you have a vertical stretch, if I grab something and I stretch it out vertically, wouldn't that get thinner, right? If I grab you and stretch you, I grab you by the head and someone grabs you by the legs and I stretch you without assuming you're not going to break your legs, all right? Then you're going to get a little bit thinner. See? There you go, girls. Go do that. All right. Vertical stretch. So this is how you do it. So this is y is equal to x squared. You have this right here, so you have -2, -1, 0, 1, and 2. So right now, all I'm doing here is I'm rewriting. These are the points for y equals x squared, normally, right? So when you have a vertical stretch, you're going to multiply these times 2. If you multiply those by 2, then you're going to actually do the vertical stretching already without thinking too much about it. So when I start at the origin, notice that the next one is normally 1, 1, but now it's going to be 1, 2. You understand that? Because I'm multiplying only this one. I'm multiplying this 1 times the 2. So that will be over 1 up 2. and then -1 up 2 also. The next point would be to the right 2 from the origin, and then up 8. All right, so from here, 1, 2, and up 8. But really, if you just draw me the first 3 points for something that's being vertically stretched, then I'm okay with it. All right, so notice that's going to look skinnier. Now, on the other hand, if you have something less than 1, this is going to be called a vertical shrink. Okay, so it's going to call it vertical shrink, and let me just show you here. If I have that, which I think I do. Now, I wish I had a color calculator, but the first graph right there, that's the original function, and the next one is the 1/2 x squared. So notice how it got wider, right? So it's the same idea. If I have something that if I grab something and I squeeze it, right? If I shrink it like this, it's going to get wider. So that's the idea behind it. All right, so we have the same points right here. And I hate to do this to you, but I'm going to have to redo this. Y is equal to x squared, xy. Then I have -2, -1, 0, 1, and 2. Then I have 4, 1, 0, 1, 4. So what I'm going to do to make this easier is you're going to multiply all these times 1/2. Right, so if you're not sure, notice that I always have that 0.00 though, because if I multiply 0 times 1/2, that's still going to be 0. Right, the next point is going to be to the right 1. Right, so it's going to be to the right, and when I say to the right, I mean this, to the right 1, and up 1/2 instead of 1. So I'm going to put a point here, and I know it's symmetric, so I can go ahead and go across and put another point there. And then the next point is going to be 2, 4, but what's half of 4? 2. So to the right 2, up 2. Symmetric, and that's it. So this is going to be wider than the original y is equal to x squared parent function. All right. Now that we know all this, all right, I'm going to show you just in general. So from now on, if you're like, man, I don't want to look at all this when I do my homework, the very last part on this notes right here tells you what each thing's supposed to be. Just condenses everything for you. If you have a negative, you're going to reflect. You're going to reflect across the x-axis. If you have a plus h, that means left. Notice that that's left, not right. Left h units. If you have a minus h, that's going to be right h units. If I have a plus k or a plus a number on the outside of the parentheses, that's going to be up k units. This is going to be down k units. Somebody walking on the roof again. You can see the thing vibrate. All right. So then finally, this last one right here. Remember that this a represents a number in front of x squared. If that number is greater than 1, like on example 7 right there, then that's going to make it a vertical stretch. So just like example 7. If a is less than 1, like number 8, notice that 1/2 is less than 1, right, on number 8. If a is less than 1, then that's going to be a vertical shrink. Now don't worry, kids. We still have another page to go. Okay? But what I did with the last class, which is what I'm going to do with y'all, is instead of covering this, I'm going to go ahead and go straight to your homework. All right, so let's go straight to your homework. And let's do a few prompts off your homework. And hopefully that'll get you halfway there. All right. Okay. Let me do a problem like number 8. All right, so this kind of combines two things for me. So number 8. First, you need to be able to know what you're going to do first before you actually start plotting anything. All right, so this one right here means left 3, right, because x is a liar. and you have a -4, which means down 4. So you have left 3, down 4. All right, so that's where my origin is going to start. So from the origin, I'm going to go left 3, 1, 2, 3, and then down 4. 1, 2, 3, 4. All right, so I got to start right there. Oh man, I cannot zoom in. But anyways, let me get this a little closer to you. Okay, so can you see that okay? No? Alright, so that's where I'm going to start. And remember those points that I had in the notes, right? 1, 1, 2, 4. Those are the same points that I have here. So I have 1, 1. And that's symmetric. And then I have 2, 4. So from that point, pretend this is your fake origin. 1, 2, 1, 2, 3, 4. And 5 points, that's all I need. I'll take that. This is going to look like that. What's the domain of this function? What's the domain of all quadratic functions? All real numbers, very good. Now the range, what is the lowest point? What is the highest point? What's the y coordinate of that? -4 and infinity, very good. Right, it includes -4, so I write a square bracket. Alright, now you pick one on the first page. Which one you want me to do on this front page, besides that one? Pick one that you think it looks hard. 6? Okay, 6 is a good one. Or 9. Yeah, 6 or 9 are honestly kind of the same thing. Alright, so I'll do one and hopefully you can do the other. So on this one right here, I'll do 6. On number 6, remember that 1/2 right here, that's a shrink. And it's only a shrink because 1/2 is less than 1. If that number is less than 1, it's going to get shorter. You might not even need to know that. Alright, on 3, and then I'm going to go up 3. So up 3. Alright, so now I'm going to start on up 3. Am I moving left or right? I'm not moving left or right, so I'm going to just start right there. And the points that I'm going to follow are exactly the same points that I had on the notes. All right. Notice that I have, normally I would have over 1 up 1. Now I'm going to have over 1 up 1/2. And then if I move over 2 from the fake origin, which is right here, if I move over 2, what's 2 square? Just answer the question. What's 2 square? 4, right? But because I'm shrinking this by 1/2, it's going to be over 2, and then 1/2 of 4 is 2. So I'm going to go over 2, up 2. Now don't forget that if this gets confusing, just look at the notes that I just finished. Alright? So then I have this right here. Domain is going to be all real numbers. The range is going to be between 3 and positive infinity. Like that. Okay. And number 9, what's the difference between number 9 and you're just moving to the left to, right? On number 9, you're moving left to, and the points are going to be the same. Okay, let me see if I want to do one more here. Let's do number 5. Okay? Alright, on number 5, you're going to reflect. Reflect left 4. Down 1, or sorry, up 1. Alright, so I have left 4, 1, 2, 3, 4, and up 1. So I'm going to put a little cross there. That's where my fake origin is located, right? That's where my very first point is going to be there, 0, 0. And notice that I'm being reflected. I'm upside down. Alright, notice that I'm upside down because I have a reflection here. So because of that, from that point, I'm going to move over to the right 1 and down 1. Right, on the next one, I'm going to move over from this point for my fake origin. I'm going to move to the right 2 and down 4. And that's it. Domain, again, it's all real numbers. What about my range? What's my lowest point?
Negative infinity.
My lowest point is negative infinity. What's my highest point? What is the y-coordinate of this point? 1. Correct. Maybe somebody said it, maybe somebody didn't. I don't know if I'm actually listening to things now. Alright, so that's that. Now let's go to the back, because the back is, I feel like you should at least have an idea how to do this. Alright, so in the next few, they're asking us to write the equation of the line. So to write the equation of the line, first of all, it says we're going to start off with this. So we start with a quadratic function. Alright, it says stretch by a factor of 2. Now I know that the stretching happens when you put a number in front of the x squared. So if it says stretch by a factor of 2, I'm just going to write a 2 right in front. Alright, and it says then shift 2 units to the right. So it should be x minus 2 because x is a liar, right? So I have x minus 2 if I want to shift to the right. Alright. What else? Okay, let's do 11. If it says shrink by a factor of a half, it doesn't matter. Shrink or stretch, that's a number that's always going to be in front of the equation. Alright, so I'm going to start off with a 1/2. It says then shift 2 units to the right. So again, I have x minus 2. Notice that it's a minus. And then I have 1 unit up. So plus 1. That's it. Make sense? I mean, I'm going through this pretty fast, but hopefully you understand that. Now in the next couple, when you actually have the graph, what you're actually looking for is you're looking for this point of origin. Alright, so this is where my fake origin is located. Alright, notice how far to the left did I move from the origin compared to this one? 1, 2, 3, 4, yeah. So I can write this as y is equal to x plus 4, right? Because I moved left, square. Compared to the origin, how far up did I go? 1, so plus 1. What else is happening besides that? Is this positive or negative? Right, I'm upside down, right? If I'm pointing down, that's going to be negative. So this is going to be a reflection, like that. Alright, I'll do one more. Number 16, and I'll explain how do you know if something's being stretched or shrunk in just a second. On number 16, we're going to start off with y is equal. Now I need to figure out how far left, how far right, or how far up, how far down. So notice that I went left 1. And by the way, leave some space right here because I got to put something there. X plus 1 square. And then compared to the origin, I went down 1. So I have a minus 1. And then I have a... Now, it turns out I have a vertical stretch, but I want you to make sure you understand why I have a vertical stretch. What's my first point that I usually do? 0, 0. What's my next point that I said over and over and over? 1, 1, right? But notice that if I go 1, 1, I am not going to intersect the curve. I'm going to be a little bit short of it. But if I go over 1 up 2, then I'm actually intersecting that curve. Does that make sense? So because that tells me my stretch right here, this distance. So it's a stretch of 2. So this has to be a 2. Alright, you're off the hook. There's a lot of homework. You only have 16, I think. Let's see, I did 6 problems. Oh, by the way, don't do 21 and 22. So don't do 21 or 22. Okay? Alright, I did 6 problems. Out of 20, you got 14. Out of all the days that I don't ask you to do a whole lot of homework, it'd be beneficial if you try to do the homework at home. Because we got a lot of stuff to cover. Alright, so try to at least have questions for me tomorrow. Okay? Thank you.